Measuring the spectral content of low-duty cycle RF signals such as radar pulses, especially the harmonic and spurious content of these signals over a wide frequency range, is a difficult thing to do with a spectrum analyzer. In this video, we'll take a look at how to use the triggered segmented sweep feature of the Tektronix real-time spectrum analyzers to very easily make this measurement in one sweep. In order to perform the triggered segmented sweep, we'll need a trigger signal that is coincident to the RF pulse. We start off by opening the spectrum display and the time overview display so we can establish the relationship between the trigger and our transmitted RF pulse. Let's open the trigger control panel and tell it that we want to trigger on the external input, and it'll switch ourselves from free run to triggered. And now we can see the leading edge of our RF pulse in the time overview display. The red bar on the time overview display indicates where this spectrum measurement is being made. And we can see it's starting just a little bit before the pulse edge and doesn't quite last the duration of the pulse. As we adjust the spectrum offset, we can tell the spectrum measurement to be made just after the pulse begins. And we can reduce the resolution bandwidth, which will result in increasing the spectrum length to a desired value. In this case, I'm going to make the resolution bandwidth equal to 30 kilohertz, and that makes the spectrum length just about equal to our 75 microsecond pulse width. We have now established the timing relationship between the spectrum measurement and the RF pulse using the external trigger. In order to measure the harmonic and spurious content of the RF pulse, we need to increase the span. So let's close the trigger panel, let's close the time overview display and the real-time DPX spectrum display, and look at the settings for the spectrum window. Our pulse is centered at 2.7 gigahertz, but let's start our measurement at 2.6 gigahertz, and let's finish our measurement at 10 gigahertz. As we can see in the display, we're not seeing really any content at all. Every once in a while we'll see a harmonic or a spurious component pop up, and we might even get lucky and see the fundamental come up here. But this is because the spectrum measurement now is free running. So all we need to do is synchronize this with our trigger. This is easily done by returning to the trigger control panel, go to the Advanced tab, and check this box which says Trigger each segment of swept acquisitions. And now each segment of spectrum that we look at and capture data on, we're going to capture with respect to that pulse using the same trigger conditions. And now within one sweep I can see the fundamental of my 2.7 gigahertz radar pulse. I can see a second and third harmonic. I can also see a couple of other spurious components that are coincident with that pulse. So what we've seen is by simply establishing a measurement relationship between a trigger that's coincident with a pulse and where the spectrum measurement is made, we can make a single swept spectrum measurement that is synchronous to a low duty cycle pulse, and in one sweep measure all the spectral content of that pulse.